All right, so we're going to talk about divisibility. All right, divisibility. Now, they give you some phrases that you need to kind of learn. All right, when you say the phrase is divisible by, that implies a remainder of 0. So the remainder must be 0. So I'm going to give you the same information a whole bunch of ways. Now here's what I mean. Can you divide 10 by 3 if you want to? Sure. But are you going to get a whole number answer when you do that? No. So don't tell me you can't divide 10 by 3. Yes, you can, but you can't say 10 is divisible by 3. Because when you use the phrase is divisible by, that means the remainder's got to be what? 0. Okay? Now, let's make sure we're clear about some things. We've said this before, but I don't know that I've actually written it down. When you say something like 3 times 4 equals 12, what's the answer called to a multiplication problem? Product. What are these numbers you're multiplying together called? Do you remember what those are called? Those are called factors. Okay. 12 divided by 4 is 3. Okay. When you got long division, the thing on the inside is called the dividend. The thing on the outside is called a divisor. What's the answer called to a division problem? Do you remember? What's the answer called to a division problem? We've got to learn these words if you got to teach them. That's called the quotient. So I'm going to ask you these kind of things on tests. So true or false? 12 is divisible by 3. Is that true or false? True, because when you divide 12 by 3, what's your remainder? 0. Not your answer, your remainder. When you do this and you multiply back, see your remainder is 0. Okay? Now, here's the other thing. Sometimes they will say this. They'll say 3 is a factor of 12. And that's got to be true. If you multiply something by 3 to get 4, you're going to divide something by 4 and get what? 3. Okay. They might say this. They might say 3 or 4, either one. 4 is a divisor of 12. And see, again, that would be another statement that's what? True. If something's a factor, it's got to be a what? A divisor. It's just factors talking about multiplication, divisors talking about division. But there's a relationship between multiplication and division. All right, let's make sure we understand this phrase. What if I told you to do this on a test? List the multiples of 5. What does it mean when I say list the multiples of 5? You know what that means? It's like you're counting by that number. Call it skip counting in kindergarten. Okay? So when they ask for the multiples, that's the product of that number and the counting numbers. What's your first counting number? 1. So what's this number? What's 5 times 1? 5. What's the next counting number after 1? 2. So what's that number times 2? 10. My next one's 3. What's that number times 3? 15. 20. I don't want you to get multiples and factors confused. Okay? Now we're about to talk about this in just a minute. So if I told you on a test to do this, list the factors of 6. Now, factors are things that you multiply together to get that number, right? So what are all the factors of 6? What would those be?
1 times 6.
1 times 6, and what else?
3 times 6.
So these would be all the factors of 6. Now, if I said list the multiples of 6, what's going to be in my list?
6, 12,
6, 12, what?
18.
18. Will it ever stop?
No.
So what am I going to put? Dot, dot, dot. So when you hear multiples, you think multiply, but it's not what multiplies to give you that number. It's that number times your counting number. So don't get factors confused with multiples, because we're going to be doing that next time. It's going to be a big deal about if you get these confused with these, it's all going to be gone. So do you understand the only overlap in these sets? What's the only number that's going to be the same as the factor and the multiple? You see it's the number itself? It's its biggest factor and its smallest what? Multiple, right? So except for the number itself, factors are smaller, and except for the number itself, multiples are larger. Okay? So they're going to ask you a lot of these things. Now, so they could also say this. They could say 12 is a multiple of 3. If you count by 3s, once you eventually get to 12. Okay? So these phrases, is divisible by, is a factor of, is a divisor of, is a multiple of, we've got to recognize those things. Now, this one's a little different. Instead of saying that 12 is divisible by 3, sometimes they'll say 3 divides 12. That's what they say, in other words, goes in 2. You don't say 12 divides 3. So this order is different than this order. So 12 is divisible by 3. In other words, 3 what? Divides 12. And the symbol for that looks like this. 3 divides 12. That bar means divides. And I think the reason they use that symbol is it's not a big stretch then to do it. Does that make sense? In other words, this is actually the order that we do long division in. This one, you'd have to flip the order to do the long division. Okay? So we've got to learn. So they give you a definition of divides on page 185, which basically requires you to have that remainder of 0. Now, they give you a couple of things in this section 1. All right, look on page 187. There's some theorems that you need to learn. And there's a theorem on the bottom of page 186. So here's what it says on page 186. For any whole number A and D, if D divides A and N is any whole number, then D divides N times A. Now, what in the world is that saying in English? Do we agree that 3 divides 9? Right? Then what they're saying is 3 would divide 9 times any other number. as long as it's a whole number. Like, what's 9 times 2? Does 3 divide 18? Yeah. What if you put a 10 there? What's 9 times 10? Would 3 divide 90? Yes. So what they're saying is, if you've got one number dividing another number, this number is going to divide that number times anything, as long as this is a whole number. Okay? Then on page 187, they say, okay, if D divides A and D divides B, then D divides A plus B. And C says if D divides A and D divides B, and A is bigger than B, then D divides their difference. Now here's what it's basically saying. Does 2 divide 10? Do we agree that's true? All right. And is really important, not or, but and. Does 2 divide 24? Let's do this, let's make it a smaller number. Does 2 divide, let's make this one 24. 2 divides 24 and 2 divides 10. Don't we agree? Then according to that theorem, 2 is going to have to divide whatever 24 plus 10 is. And sure enough, what is 24 plus 10? So does 2 divide 34? Yeah, it's got to. If 2 divides both of these and doesn't just divide their sum, it'll also divide their difference. And what is 24 minus 10? 14. And isn't it true that 2 divides 14? So if it works for both, it's going to work for their sum and for their what? Their difference. What if it works for one and it doesn't work for the other? 2 divides 24, right? Does 2 divide 5? It doesn't, does it? So when they put a slash through it, that means doesn't divide. Then 2 is not going to divide their sum, and 2 is not going to divide their difference. And sure enough, 2 doesn't divide 29, and 2 doesn't divide 19. So if it works for both, it'll work for their sum and their difference. If it works for one and not for the other, it's not going to work for their sum and difference. Okay? Now, there's some shortcut rules that you probably know, and then some that you may not know. And what we're going to do after this is we're going to learn to do prime numbers and factor trees. Okay? So it's going to be crucial that you know some quick rules that'll be helpful. Now, all the rules don't have shortcuts, but there's some that do have shortcuts. So I want to talk about some divisibility rules real quick that you need to learn. And some of these you will already know. All right, divisibility rules. These are just shortcuts that keep you having to do long division. Okay. Now, what am I talking about? Here's what I'm talking about. How do you know for sure if, let's put in different colors. How do you know for sure if a number will divide by 2? How do you know if a number is divisible by 2? Without doing long division, how can you tell? All right, if it's an even number. All right, but if I don't know what even is, what's even? I'm glad to get a number that's got 49 digits. And without doing long division on that 49-digit number, I need to know if it's divisible by 2. I mean, I can divide it and then see the remainder. But if I don't want to have to do the division, how can I know by just looking at the number whether it's divisible by 2 or not?
You can look at the last number.
Okay, what's the last number got to be?
Even.
All right, but again, we're using that number even. Well, if I'm doing division, I'm in 3rd grade, so I'm like 8. So tell me what I can do with that last number, Annika. So I'm looking at the last digit. So Annika says that I've got this long number.
If you divide it by 2, the last number.
Make it even easier. I'm only 8.
It's got to be like the last number has to be 0, 2, 4, 6, or 8.
There we go. So I can do that. So if you want to check for 2, The last digit. So I'm talking about when I say last digit, I mean on the right. Does everybody understand that? Must be either what? 0, 2, 4, 6, or what? 8. See, I don't care if it's got 49 digits. All I'm looking at is the last one. So that number's got to end in 0, 2, 4, 6, or 8 to be divisible by what? 2. And I'd much rather just look at that last digit rather than take this long number and do long division by 2. All right? What's the shortcut to see if 5 is a divisor? All right, so the last digit's got to be what? 0 or 5. Okay? So that last digit on the right must be this time 0 or 5. So again, this was divisible by 5, but this long number is not divisible by 5. All right, what's the shortcut without doing long division? How do you know if the number is divisible by 10 or not? Last digit's got to be 0. So that's pretty sweet. I don't care if the number's got 9 million digits. I only care about the last one. So without doing long division, I can tell you if the number is divisible by 2, by 5, and by 10 just by looking at the very last digit. All right. Does anybody know how to tell if a number is divisible by 4? The number represented by the last 2 digits is divisible by 4. Now remember, what is divisible by mean? The remainder would be what? 0. So if I had this number, now you could divide by 4. Is everybody with me? And do long division, but that's a lot of work. So instead, my shortcut is I just look at the last 2 digits. What number is that? Is 16 divisible by 4? Then so is 24,612,016. Now, what if this was a 3? Is 13 divisible by 4? No. All right, what if this was 0, 8? Yeah. Now, this one freaks people out. Is that divisible by 4? Yes. You can't pull any out. You can't pull any out. What's the remainder? 0. Okay. So for 4, you look at the number represented by the last 2 digits. That number is divisible by 4, which means when you divide by 4, your remainder is what? 0. Now, the way you check for 8, that's the number represented by the last 3 digits. Is divisible by 8. Right, so what do I mean by there? If I want to know if that number is divisible by 8, which digits do I look at? The last what? 3. And you might say, well, I don't know if that's divisible by 8. I don't. You might. But I can go over here and do 142 divided by what? 8. Isn't that way better than dividing this big number by 8? All right, can I pull any 8s out of 1? No. All right, can I pull 8 out of 14? How many? 1. That give me 62. How many 8s can I pull out of 62? 7. Just my remainder 0. So no, that number is not divisible by 8. Are we okay? All right, now, you know how you check for 3? This one you may remember. You probably did this one in elementary school. Do you know how to tell whether it's divisible by 3 without actually dividing it? Anybody remember? You add the digits. The sum of the digits is divisible by 3. All right, the sum of the digits is divisible by 3. So look what that means. You see this big long number up here. Add the digits. What's 7 plus 9? You tell me. 16 and 3 is what? 19 and 6. 25 and 3 is 28. 29. What's 29 and 4? 33 and 2. Is 35 divisible by 3? Then neither is this number. But now, if that had been a 3, wouldn't the sum have been 36? So is 36 divisible by 3? Then so is that number. So for 3, you just add the digits up. The same thing works for 9. The sum of the digits is divisible by 9. So like I said, if I add these up, I get 36. Is 36 divisible by 9? And so is 79,363,146. And then the way you check for 6, 2 and 3 must be factors. So both of them have to work. If both of them works, 6 works. If one of them or both of them don't work, 6 doesn't work. All right, so here's what I would do on a test. I would give you a really long number. So here's your really long number. All right, tell me which of these numbers are divisors without doing long division. So if you got your calculator or just pencil and paper, so I want to know which of these are divisors of this number. Now on your second test, there's going to be part of the test where you have a calculator and part of the test where you don't have a calculator. And this will be part of the test where you would not have a calculator. So you're not going to be able to just grab the calculator and divide that number by 4, or grab the calculator and divide that number by 9. You can do it by hand, long division. but not with calculator. So how do I check to see if 2 will divide into that number with no remainder? What do I do? I just look at the last digit, don't I? So if it ends in 0, is 2 a factor? So 2 is a factor. All right, how do I check for 5? Again, I just look at the what? Last digit. Is it end in 0 or 5? So 5 is a factor. Is 10 a factor? How do you know 10 was a factor? Because it ended in 0. Now how do I check for 4? The last 2 digits. What number is that? Is 20 divisible by 4? So 4 works. How do I check for 8? The last what? 3. Now I'd have to go do long division. But I'd rather do this long division than that what? Long division. How many 8s can you pull out of 4? 0. All right. How many 8s can you pull out of 42? 5. Are you going to be able to pull 8 out of 20 with no remainder? You aren't, are you? Because you're going to go how many times? 2 times. And aren't you going to have a remainder? So is 8 a divisor? No. All right, how do I check for 3? Remind me. What do I do? All right, when you added all of these digits up, what sum did you get? 30? Is 30 divisible by 3? Then 3 is going to work. How do I check for 9? Don't I use the sum again? Is 30 divisible by 9? No, so I'm not going to write down 9. How do I check for 6? 2 and 3 both have to work, but 2 and 3 both work. So it's 6. And I want you to put them in numerical order. That's the ones from that list that are divisors. There may be other numbers, but I know these work without doing long division. So if you forget your shortcut, you have to flip to the back of that test and do some really horrendous long division problem by hand. Okay. All right, so is everybody okay? Okay, on divisibility rule. Question?
So would 0 and 1 be divisors also, or those aren't?
No, they're divisors. In other words, now when I say 0 is not a divisor, but 1 is. 1's a divisor of everything. It's just, it doesn't have a shortcut. It's just 1's a divisor of what? Everything. Now, how do I know that 0 won't divide anything? You can't have, in other words, I can have 0 on the top, but I can't have 0 on the what? On the bottom. So 5 divided by 0 would look like this. Is everybody with me? And what? So 0 is not a divisor of anything. I can divide 0 by things, but I can't divide things by 0. Very good question. Or any other clarifications? I'll talk about prime numbers for a minute. Now, a lot of times, the definition that you learned in elementary school is not going to work. So let's make sure we understand. What's a prime number? Give me an example of a prime number. Let's start with that. What's an example of a prime number? 7. What's another example of a prime number? 5. All right. So obviously, is 8 a prime number? No. So you know what a prime number is. We just have to fix the definition. How did you learn? How did you know 7 or 5 was a prime number? What were you doing in your head?
I think I mean multiply anything to make that number without 10.
All right, so in other words, you're saying that the only factors of that number are 1 in itself. Okay, that's not exactly right, but it's close. All right, the definition of a prime number is this. Has exactly 2, I'm going to put this word in parentheses, distinct factors. Because a lot of times they'll tell you that a prime number is a number whose only factors are 1 in itself. Well, see, the problem with that is, what are the factors of 1? 1 and itself, right? And 1's not prime. Okay? So the definition of prime number is it has 2, and the reason I put distinct means different. And see, 1 times 1, those are not different. Everybody with me? Now, if it's not prime, it's called composite. So a composite number has more than 2 factors. So a minute ago, you told me the factors of 6 were 1, 2, 3, and 6. So that's more than 2, so that's a composite number. All right? And then write this little starred sentence. 1 is not prime or composite. So it's the only counting number that's not prime or not, it doesn't fit either definition. So if you tell your second graders that the definition of a prime number is its only factors are 1 in itself, by that definition, 1 would be prime. So prime numbers have exactly 2 factors, composite numbers have more than 2 factors. Now, there's a theorem that is very important in your books on page 201. So important on your second test, I'm probably going to ask you to state it. Okay? So it's called the fundamental theorem of arithmetic. Now, that sounds pretty important, and it is. It's the foundation. Look what it says. Each composite number can be written as a product in primes in one and only one way, except for the order. So on your test, I'm likely to say, state the fundamental theorem of arithmetic. So you better learn it and be able to just write it out. Now, what's it saying in English? Right, here's what it's saying in English. Now, it only applies to composite numbers. It doesn't apply to prime numbers. It applies to composite numbers. It says if you have a composite number, you can write that number as the product of only primes. So if somebody gives you a 36 or 100 or 56, you've got to be able to write that as just prime numbers multiplied together. Now, that is called the prime factorization. That product is called the prime factorization. So on your test, I'm likely to say something like, write the prime factorization of 36 or of 100 or 56 or 275. I mean, they can be big numbers. Now, most of us can't just automatically go to the prime factorization. So what you learned in elementary school to do is, most of us use factor trees together. Now let's remember what factor trees are. With factor trees, you list any 2 factors of this number that you want to list. It doesn't matter. Just don't use 1 in the number. So give me 2 factors of 36. What are 2 things that will multiply together to give you 36? 6 times 6. Now, somebody else, let's do it. What else could give me 36? 4 times what? We got our multiplication facts, but you're not going to have a calculator. What gives me 36? 4 times what? 9. So Katie might have said 4 times 9. Amber might have said 6 times 6. It doesn't matter. Here's the rule. If it's prime, you bring it down. If it's not prime, you break it down. It's 6 prime. They give me 2 factors of 6. All right. 2 times 3. This is the problem gives me 6. Is everything a prime? Is 2 a prime number? What are the factors of 2? 1 and what? 2. How many is that? 2. 2 is prime. Is 3 prime? Yeah, only factors of 3 are 1 and 3. That's 2 numbers. I know to quit when everything on the bottom of the tree is prime. Now, what I'm going to give you next is this. This is a GAN rule, not a math rule. So you can do that in class when you teach. This is a you don't mean to misgrade your test rule. I want the prime factorization written in order. So I don't want you to write 2 times 3 times 2 times 3. I want it 2 times 2 times 3 times 3. I want it in numerical order. Easier for me to grade. I don't want to be jumping around hunting for your fifth, your fifth 7 or something. Okay? Now, what if we had done this? Well, it's 4 prime. So break it down. What gives me 4? 2 times 2 is 9 prime. What gives me 9?
2 times 3.
See, I'm going to get exactly the same answer. So it doesn't matter what factors I start with. I just have to keep breaking them down until they're all prime. But we're not going to leave anything dangling somewhere. Okay? Like, if you did this, isn't 36 also 2 times what? 18? Oh, I'm sorry, 2 times what? We good? It's 2 prime.
Yes.
Then bring it down. Don't leave it dangling up there. Is 18 prime?
Yes.
Then break it down. What gives me 18? 6 times 3. Is everything prime?
Yes.
So I got to keep going. Is 2 prime?
Yes.
So bring it down. Is 6 prime?
Yes.
So I break it down. What gives me 6?
8 times 3.
It's 3 prime.
Yes.
So that's what I mean by if it's prime, bring it down. Do you see that no matter what I start with, as long as I do it correctly, I get the same answer? Now, there's another way of writing this if you want to. Instead of writing 2 times 2 times 3 times 3, could you use exponents? So you could write it as what? 2 what? Squared times what? 3 squared. Either one of these is fine with me. All right, so you get me the prime factorization of 56 real quick. Okay, so find me the prime factorization of 56. What gives me 56? Give me 2 numbers.
9 times 6.
9 times what?
6.
9 times 6 is going to be 50 what? 4. Because I need 9 times, I need 956 is what? 7 times what? 7 times 8, isn't it? It's 7 prime. So we bring it down. What gives me 8? 4 and 2. Are all those prime? So I got to bring down the primes. What's 4? It's 2 prime. So bring it down. Is everything on the bottom prime? So what's my prime factorization of 56 going to be? 2 to the what? 3rd times what? 7. Everybody okay? So if you don't know your multiplication facts, that's part of your homework. Start learning. Now, the other thing that's going to be crucial is this. You have to know what numbers are prime numbers. So there's something called the sieve of Aristophanes. He lived in ancient times. Now I'm going to start it, and part of your homework is going to be you're going to finish it. Now a sieve, have you ever seen things like a pan for gold where they would dip that thing down in the water? So it was a pan that had like mesh bottom, and they would dip it up and they would shake it. And so what would happen is the water and the little pebbles and the sand would all fall through, and it would catch the gold. So a sieve catches what you want it to catch. So this sieve is going to catch our prime numbers. Now, so what we're going to do is when we know something's prime, we're going to circle it. When we know it's not prime, we're going to cross it out. Is 1 prime? No, we said 1's not prime or composite. It's 2 prime. So we're going to circle it. Now let me ask you this. What about all the multiples of 2 though? Are they going to be prime?
No.
No, because won't 2 go into them? So what am I going to do with all the multiples of 2? Cross them all out. They're gone. Now, 3 is 3 prime. So what do I do with prime numbers? I circle them. But what about all the multiples of 3? Would they be prime? No, because if it's a multiple, that means that 3 is a factor of it. So all the multiples of 3 are going to get crossed out. Well, 3 times 2 is 6. It's already crossed out. But what else do I need to cross out? I got to cross out this 9. And then 3 times 4 is already there, but I got to cross out 3 times 5. Is everybody with me? So all these multiples of 3 have got to be crossed out. 1, 2, 3, it's gone. 1, 2, 3, 27's got to leave. 1, 2, 3, it's already gone. 1, 2, it's got to go. And what's the next number that's not crossed out? 5. Isn't it a prime number? So what do we do with prime numbers? We circle them. But what about all the multiples of 5? All the multiples of 5 have got to be what? Got to be gone. So 5, 10, 15, 20. Oop, I got to cross out 25, 30. Oh, I got to cross out 35, 40, 45, 50. 6 is gone. It's 7 prime. But what about all the multiples of 7? They're going to get what? Crossed out. So part of your homework is you're going to finish the C, but your C is going to go up to 100. So what you should have before you come in here next time is you should have all the prime numbers up to 100. Because you got to be able to list those for me if I ask for it. Where's your homework going to be? On Moodle. And be looking for that video, because some of y'all aren't doing those videos, and those are zeros for pop test grades. Okay? And always notice when they're due, because I'm not taking them late. Those should be easy 10s to help your grade. Not zeros because we're not doing it. Okay? Come see me if you need some help.